stuff. So just fill that out, and feel free to be harsh. I'm a thick skin. And first, I want to thank everybody for coming out. I'm Jamie, if you haven't met me, and I work in the Learning Lab. So thanks for coming out. I know you're all super busy, and I hope this presentation is informative. I want to treat it more like class than a presentation, partly because I think people learn better that way, and partly because it'll make me less nervous. So feel free to ask questions at any time. I welcome them. So this is Intro to Regular Expressions. Today I'll be going through the definition of a regular expression, kind of a loose definition. Talk about kind of the bad aura that regular expressions have. By the way, can everybody hear me okay?
Yep.
Yeah? I'll also talk about things that might whet your desire to use regular expressions, the features and possible uses. Next, I'll talk about literacy, how to read and write regular expressions, and why you should be able to do so. And then we have a little bit of potpourri, just random odds and ends to finish up with. So this is a simple regular expression. Not the simplest, but basically what it does is match Wharton email addresses. What does that mean? Let's see. What is a regular expression? I'm not going to go through the formal definition. You can probably look that up on Wikipedia. Basically, I think it's best to think of them like pattern matchers or text processors or mini specifications. For example, that previous regular expression is a specification for all valid Wharton email addresses, basically. So how are they processed? Well, we feed a regular string into one end of the regular expression, and out comes various output. Well, that can be a Boolean, perhaps. It can be a set of matches, or it can be a transformed string. So there's our possible outputs. What is this heart thing? Well, it's, you can think of it as sort of a machine. One method that people use to create these machines and software are finite state automata. So they're basically like flowcharts. This is a visualizer for regular expressions that will produce the corresponding finite state automata. So let's say we have a regular expression A. What that does is says if the string has an A, then it's good. So we have this little graph here that shows that when you input an A, it accepts an A. So let me clear this. If I just input an A, the little bubble moves from the start to the accepting state, which has a double circle. And so I won't show any more of that, but you'll see these later. So why do regular expressions have bad reputation? There's this famous quote by Jamie Zawinski, who worked on, I think it was Emacs, and someone suggested integrating Perl into Emacs for its regular expression functionality. And Jamie was having none of this. He said, some people, when confronted with a problem, think, I know, I'll use a regular expression. Now they have two problems. He felt that regular expressions were overused, and people just use them for problem domains that they weren't designed for. So that goes into part of why it has a bad rap. They're overused. Well, people think they're overused, and perhaps that's true. And they could be unintelligible. When you see a long regular expression, it can be very confusing looking at it. I'll try to dispel some of these myths. First, talking about the overused aspect, I'll talk about good uses and bad uses. And concerning the unintelligible part, I'll try, that feeds into the whole literacy section. But first, just to scare you a little bit, if you haven't seen any of these are kind of cool. These are really obscure regular expressions, probably what people think of if they have a really bad opinion of regular expressions. This first one is used to validate the entire email specification. The email spec is actually really large. You can embed comments in emails and stuff like that. So this is a really large regular expression to validate them. Next, this is a regular expression that solves a Sudoku. For those who don't know what that is, that's this little puzzle at the bottom right. What it'll do is it'll match a inputted puzzle, and it'll capture all the correct answers as a result. So this may crash my computer. Hold on. Yeah, it's working really hard.
In JavaScript?
No, I think it's an image.
Okay.
So this is, I don't know if you can even see that from back there, but this is just a huge regular expression, computer generated, to solve a Sudoku puzzle. So I'll close that before my browser crashes. Okay. So before I go on to the next section, are there any questions? No, everyone's good. Okay, as I mentioned in this section, I'm going to talk about things that might whet your desire to use regular expressions. First, I'm going to talk about the features of regular expressions, just the very basic ones, because after all, this is an intro. So first off, in using regular expressions, you can specify literals. And literals just match the characters themselves. So for example, if I wanted to validate a string, I wanted to say a string doesn't have ABC, I'd literally just write ABC, and that we could use that to match the string. That's probably one of the simplest regular expressions. And here's, below, this is the representation of that regular expression in a finite state machine. So, I probably won't go over these again, but you can check them out later because I'm going to send out the slide link if you're interested. So, regular expressions have kind of like a Boolean OR sort of mapping with brackets. These are called character classes or character sets. So let's say we want to match Bark or Bask. Well, we can write BA and use the brackets to specify the possible options. Notice that the R and the S are within the character class. That means we can take either. So, when we're going and matching the string, we look for a B, then an A, then an R and an S, or K. And that will match Bark or Bask. Character classes also support negations. We can say we don't want any of these options. So we can use this regular expression up here, right here, if we want to match everything except crap. There are also shorthands for certain commonly used classes. So one thing that is very common for people to search for are all the ASCII alphabet characters, or the US alphabet. I'm not sure what to call that. And also digits. So this is right here a digit class, and this is the a word, which is a digit or a number, and the S is a space. There are corresponding character classes. Some languages, they support the Perl style, and some the POSIX, some both. So it's really going to be left up to you to figure that out with your respective language. Cold Fusion supports POSIX. I think we saw that. We looked it up the other day. Adam did.
Hey, Jamie.
Yes.
I have a question about
Yes.
that one. Actually, that's a crap one.
Yes.
So, the negation, would it work on the whole word, or will it only work if you pick a certain
It will only work on a certain letter. So
So you can't
No,
Like select the letter and the word.
no. So you couldn't negate the entire crap. Like so that kind of thing is difficult with the basic regular expression syntax. Really, when you're programming, you want to match crap and then do a not in the programming language. So you might do a find, find crap, and then in your programming language, just negate that. So, but not within the regular expression. And I can show an example of that later, if you remind me. Any other questions? Yeah, so I just wanted to say real quick, I'm going to go over the features, then I'm going to go over some examples, and then some sample uses. So don't worry if this is like flying over your head or anything, since I'm going to come back to it. Next feature are quantifiers. We can say how many times we want to match a certain pattern. So that's actually an error. So a question mark will match one or more of the pattern. So if we want to match, we want to say, does the string have one or more A's? Then we can do A question mark. The asterisk matches 0 or more of the character. So if we wanted to match 0 or more A's in a string, then we'd use A star. The plus matches more than 0. And the N and the N and M just match a certain amount. When you know exactly how many you want, or if it's between a certain range. This is actually an error here. This should include, this should be BC star. So just going through this real quick, let's say we wanted to match a string that did match this. It matched like, it was like A, B, C, B, C. So remember that we start here, and we have an accepting state here and here. So we'd say the first character is A. We test that. If it's A, then we go here. If the next character is either B or C, then we go here to an accepting state. It can also, the next character could also be B or C, and we would just keep on repeating the accepting. That's if this says BC star, which is 1, or no, 0. No, that's plus, I'm sorry. Plus, which is 1 or many. Sorry, that's a little confusing, isn't it? Okay, the next feature is grouping. Sometimes we want to match a whole set of characters as they are, many times, or we want to do something special with them. With groups, we can extract whatever's inside the parentheses, and we can also apply quantifiers to them. So if we wanted to match multiple ABCs patterns, then we would use a group. And I'll show some like concrete examples of that later. So let's say we have a string. It has like a bunch of stuff with fruit and junk. And we have regular expression that's over here. That will basically match anything that ends in PPLE. Because we have a character class here, any letter, one or more times, ending in PPLE. If we were to apply this regex using whatever syntax is valid for the language you're working with, then we would match these words. Apple, scrap, snapple, pineapple, because they all end in PPLE. Any questions? Okay, and there's other features, but I wanted to keep it simple. So I'm not even going to go over this slide. You'll see this later. And if you actually start using regular expressions, a lot of this will come naturally. So I'm just, going to bypass it. So this is a stopping point. I have a little stop sign here. Any questions? We will have some concrete examples, but like not too many. So if something went like whoosh completely over your head, then now it's time to ask. But as long as you have a basic idea, that should be good enough.
I have a question.
Yeah.
So maybe a helpful thing to know would be the example that you used with Apple, the
Yeah.
PPLE.
Mm-hmm.
So what's the difference between using a regular expression for that and just doing a find,
Mm-hmm.
like a wildcard search for PPLE in a string?
The key difference is that it's difficult to get the entire word. Like, let's say I want all the words that have the PPLE. It's difficult to get that out because, let's say we did a regular find. Usually, in whatever language you're using, that gives you a position, right? A numeric position. Then you'd have to take that position, backtrack to the last space, for example, if you wanted the word. Do you know what I mean? And then to extract it. Does that make sense? So like, let's say we did find cold fusion for PPLE. It might give us like position like 2, position, I don't know, whatever that is, 20, 26 or so, right? But then at that point, we just have the positions, and we could extract Apple very easily. We would say for each of those positions, extract 5 characters after that position. But we don't know going back how far to look for the space to know the beginning of the word. Does that make sense?
No, I do see how that could be an advantage. I guess I'm just confused about how regex knows that space is the delimiting thing in your string.
Oh, okay. So only because I specified A to Z and not a space inside.
Oh, okay.
Yeah.
All right.
That's something I kind of glossed over. It's like fully like detects all white space and everything. So it's exactly literal. Like if you have a space in something, and you don't have it in your regex, it won't work. It won't match anything. Also for like tabs, new lines, you have to explicitly like state what you're expecting.
Also, correct me if I'm wrong.
Yes.
If one of the words was like snapple with a D at the end, would the regex find it versus the find wouldn't find it because it
Well, yeah. It would find it, and what would happen is, I think, depending on your regex flavor, like if you were to use this in JavaScript, I'm pretty sure it would just chop off the D, snapple.
Interesting.
So it would just chop it off. Now there are regular expressions to get the entire word. That's something I'm not going to go over, but basically you use a zero-length match called a word boundary. It can actually tell you where does a word begin, where does a word end, using any white space around the word. And that's not something I'm going to go over.
So if you had a bracket, A to B at the end of the PPLE, that would
Yes.
Apple.
Yes, and you could add a asterisk, which would say 0 or many. So in case there was nothing after, then there wouldn't need to be anything after.
If I remember right, if you had a second Snapple at the end of a string,
Uh-huh.
it would then return Snapple twice
Yes.
in the result set, correct? It's
Yes.
not- so it's
Yeah, and it also
instance of the match.
it also depends on your flavor. If you were to put this directly into like Cold Fusion or something, you wouldn't even get the words. I think you might get positions of the words, so it's different. So you have to, if you're interested, then you have to kind of drill down and know what your respective language supports. I tried to be language agnostic here. Any other questions? Again, feel free to stop me as I continue. So now I'll go over some simple examples. These should clarify things if, just the previous slides haven't. So we have 2 regular expressions here. There's groups, quantifiers, and these slashes are just what I use to delimit regular expressions, just the start and end of a regular expression, because in certain languages like JavaScript, Ruby, maybe Python, I don't remember. You can actually just put a regular expression in the code like this, and it'll kind of like wrap it in an object. Okay, so what does the first regular expression match? It matches to be or not to be. These are both valid matches. That's because we can either have or not have a not. That's a little confusing. And that's what the question mark says, 0 or 1. Okay. What doesn't match? Well, this capital not to be doesn't match because regular expressions are case sensitive. Depending on your flavor, again, you can turn that off. Cold Fusion has RE find no case. So just be aware of that. Also, it doesn't match not to be with 2 spaces or however many that is. Because you have to explicitly state how many spaces you'll accept. To solve that very simply, we could add a plus after that space in the 2b, or the 2 space plus. So this regular expression matches lion, tiger, bear, and lions, tigers, and bears, kind of. So here we have lion, tiger, bear, and lion, lion, tiger, tiger, bear, bear. That's because we have a plus after each group. So we have to have lion 1 or many times. We have to have tiger 1 or many times. We have to have bear 1 or many times. What doesn't it match? It doesn't match a lion, tiger, bear string with spaces, because I didn't put a space in here. And it doesn't match lion, bear, because we have to have 1 or many tigers.
Where would you put space? If you wanted to know.
Right after the plus. Pluses.
It would be like a character. How would you say this? Like
Oh, just space.
single quote, space, single quote.
No, just a space.
Oh, just a space. Because the whole thing is like
Yes.
inside of the string. Okay.
Yes.
Yeah.
There are certain characters, I kind of glossed over this in the literals section. There are certain characters you have to escape. Most characters you don't have to escape. But, for example, the plus, it's kind of implied that you have to escape it, because otherwise how does it know? So, these are examples of alternation. So within a group, we can say we want one thing or another thing. So what do these regular expressions match? By the way, the alternation operator is the pipe. I don't have further explanation. But basically, the first string matches either, or the first regular expression matches the string the best of times, or it will match the worst of times. And the second regular expression will match either liberty or death. So you can see that one possible use of regular expressions is when you have, like, a lot of people will match one string, then another, or another, and another, and have the same program path, regardless of which string they match. So a regular expression offers a quick, concise way to state, accept all of these. And this is another stopping point, so any questions? Okay. Now I'm going to talk about some sample uses, and this will actually have real code if you're that type of person that likes to see code. I know I am. So I separated them into 4 kind of loose categories: search, normalization, extraction, and validation. So one thing we can use regular expressions for are finding text in files, which is especially useful when the string that we're looking for is variable. I think Russ went over some Unix utilities in a previous talk, so I'm just going to show a quick grep. What I'm going to do is look for files containing ampersand to do or exclamation to do. And that could be because maybe different programmers worked on something, but they both use to do, or you could use it for something very similar. But this is pretty much a toy example. So hopefully you guys are familiar with this. Was it the character class stuff? Yeah, here you can't see it. The way I want to say is either accept an exclamation point or an ampersand before the to-do. So that's it. It just prints the lines containing to-do. And true, you could do the same search by searching for both strings. But obviously, the more strings you start to have, the more variations, the more of a headache that'll be. Okay, and another possible use is finding all the Cold Fusion tags in a directory. Why would you want to do that? You probably won't want to do that exact thing, but hopefully, I find my notes. But hopefully it can lead to other possible uses in your mind. All right, I'm going to wing it. It shouldn't be that bad because I should kind of know this stuff, but I'm not like an expert by any means. Okay, let's say we want to find all the Cold Fusion tags in this directory. Well, Cold Fusion's tag starts with this CF part, and then some stuff that is not a closing angle bracket, and then an angle bracket, right? So I think that's it. And that's not it. Plus. All right, I'm not sure what's up with this closing angle bracket, but it's because I put the plus inside the character class. I'm not sure if you guys saw that, but okay, maybe not. I don't know. But leaving off the ending angle bracket, we were able to search for all the Cold Fusion tags. And true, you could do that with a regular string, but yeah, I wish I knew that angle bracket. I'll just move on to the next example. So when you're using regex in code, there's various libraries depending on your flavor. I'm not going to go through these, but you can see in various languages it's different. So that'll be up to you to learn. And Wikipedia has a comparison. The biggest thing to note is that not all implementations are the same, and not all implementations support every operator. For example, in grep, I couldn't use a star. That's something I looked up yesterday. So it doesn't support star. But no, it does support star. That's my mistake, I think. Okay. It supports star, but it doesn't support plus. So there are ways around that, but again, it's dependent upon what you're doing. Okay. So another use in the search space is programming language detection. A few of us were working on a command line script. What it did is it took a file from standard in, and it would detect the language and post it to a paste bin so we could review. So I will just show some quick code. It's kind of ugly code, but gets the job done. It's Ruby, just an excerpt. But basically, it has a bunch of regular expressions, and if the piece of code matches the regular expression, it says, what kind of code it is. So, for example, this first one searches for a starting angle bracket and a PHP, and then returns PHP. And there's various. So another use is syntax highlighting. You may have seen on the wiki that a bunch of stuff is syntax highlighted code. That's via an external library called like Syntax Highlighter or something. This happens to be a Cold Fusion adapter or plugin for that syntax highlighter. So basically what's going on is this guy is, or girl might be, is specifying a space-delimited list of function names and keywords, and then building a regular expression from each to perform the syntax highlighting. Some other uses one is normalization. So especially in like large organizations with legacy systems, I used to work for a pharmaceutical company, and all of their systems were in like COBOL. So whenever I wanted some data, it'd be coming to me in a flat file. And so sometimes you'll need to quickly process a file, and you don't want to write a bunch of code to do it. If you're somewhat familiar with regular expressions, you can just, it's like that. Especially useful for one-off processing. A lot of times we'll need to load a new application with users, and we'll give someone like an Excel form or something, and then they give us back something and it's like totally not normalized. Everything's like inconsistent. It might be like a user list, and it might be like some might be first name, last name, first name. Some might have Mrs. in them or Mr. And that can be hairy. That's a one-off use. You might not want to like program something, and you might not want to do it manually. There might be like hundreds of names. Also normalizing phone numbers and zip code. That's something you might also have to do for various reports, legacy data, and part of the user list as well. So I'm just going to show an example of normalizing a user list. So obviously it would be easier to do this by hand since there's only 4, but imagine like there's 400. So first off, we know that probably any commas in the code or in the list are like last name, first name. So that is what I'm going to correct first. What? How do I do that? Where? View. Oh. Okay. Okay. So first I'm going to reverse the last names and first names if it happens. So I'm going to say any word character, an alphanumeric character, so one or more of them, then a comma, then a space. The /s searches for any white space. So if there was a new line, if there was a tab or something like that, it's just generic for that. I could also do a space if I wanted, but I'm just going to do the /s. And then we have the first name, a bunch of more word characters, and I just want to reverse them. So part of extraction is that depending on your regex flavor, the machine will put the captures in various placeholders. So in this example, we have the first group in $1 and the second group in $2. So basically, we're just swapping them, and we're not capturing the comma, if you notice, right here. So that won't come through. Okay? Okay, so I'm not sure if that was too quick, but it basically changed Callahan Jake to Jake Callahan. Okay, and imagine that propagating for 500 names. Yeah.
For that space, that would have been any number of spaces?
No, that would have been 1.
Only for 1. So if you had a typo or
yes.
something like that, it would not have picked that up.
No. What we could do, if I was actually using this, I would take a quick scan. That way I could know kind of what to expect. But so you could also add a plus, and that will just, capture, that will match any amount of white space. So, okay, so next I'm going to strip the salutations. If I encounter a Mr., Mrs., or Ms., what I want to do is replace that with nothing. Okay, and that left an extra space. Now, what I probably should have done is say, if there's any amount of space after, then I also replace that. All right, so now we have it's kind of normalized. We can use this user list to actually insert into a SQL database real quick. I either like to use regular expressions or Excel for this. So, whatever is faster is good. So basically I'm going to match the beginning of a string. And I don't think I went over that with you guys, but if you're interested, then you'll definitely find that. And I want to match anything that's not a space. So I'm using white space to break up the first name and last name. And then I'm accepting any amount of spaces between the first name and last name. And then I'm just going to capture everything else. Okay, so, that's something I use regular expressions for. Not so much, I haven't used them for it here, so I don't know if that's applicable to you guys, but I used to use them all the time in my previous job. It's because people would be giving us just non-normalized data all the time. Okay, I have one other example, and that's normalizing a phone number list. So that's actually super long, the regular expression for that. It's not super long, but I can't read it and type it. So, and I'm kind of running short on time, so I'm going to just skip that. But if you're interested, it'll be in the presentation when I send it out. So another use is extraction. It's kind of related to search and normalization, as you saw, because I kind of extracted first names and last names in that previous example. But, sometimes we want to extract URLs or email addresses from a body of text. For example, lots of blogs, if you just put in, a URL, it will automatically convert that to a link when it's displayed to the user. So, that's definitely a use of regular expressions. So this is a little plug. I work on this really simple Firefox extension called CiteThis. And basically, so you go to a website, right, and you're doing some research, and you want the citation for it. You can click this little thing, and it'll generate the citation for you. So one of the things I wanted to do is get the author of a site. So it's weird because the author for some articles for CNN is in a byline at the top, and then for this one, it's that's super weird. So I actually have code to custom handle certain very popular sites. So I'll just show that real quick. Okay, so this is a kind of a namespace that handles CNN. So in this line, I'm getting an element, and this corresponds to that element I just showed you, an HTML element, this one that contains the text. And if that element exists, then I search for CNN's contributed. And it will pull everything in between that, and those are the authors. So that's one example use. Another example use is I had to pull the analysts from this page. Someone wanted the analysts and the companies that they belong to. So notice in this case, there's like a new line or a break separating them. And in this case, there's like an of separating them. The thing with HTML is like you never know how much white space there's going to be. So I found regular expressions handy. I just split on the of with white space in this case, and I can get the name and the company. In this case, I can split by either a break or a new line or whatever else, and that'll give me the company name. Another use is validation. So, that's kind of obvious when we're filling out HTML forms and people want to prevent users from entering certain stuff. We can validate against that. What I really want to talk about here is like casting versus string matching. So let's say you want a date. Do you want to use a regular expression to validate that? You might instead want to cast the date as a JavaScript date object, and just validate that way. What you want to do depends on your problem domain and your problem space. And I'll actually show a case where you should use regular expressions to match a date. Because usually you'd want to cast instead. But first I'm going to show this jQuery plugin. And what it does is it only allows the user to input certain stuff. I'm typing away on this keyboard and it won't let me do stuff, right? It only accepts numbers and it corresponds to this mask here. So this guy uses regular expressions to handle that. Another big use in this space is stripping HTML. The JavaScript library prototype, which some of you may be familiar with, uses this particular regular expression to strip tags. So that's another common use. So having said all this, when do you avoid using regular expressions? Well, a lot of people will use them to parse HTML. That's probably, we can forgive it if it's a one-off case, but there's actually solutions to parse HTML, including DOM and XPath. Also, when the performance is really critical, you might try to really formulate your solution as a set of string matches rather than a regular expression, because regular expression matching can be CPU intensive. If you think back to the finite state machines that I showed earlier, you can imagine with a very complex expression, there's a lot of processing that has to happen as compared to a regular string matching. Also, stateful processing. Part of the definition of a regular expression is that the language you're matching is regular. I'm not going to go into that, but it's not really designed to match sort of like things that require state. So if you were to ask me to match a string that contains an odd number of A's, difficult with basic regular expressions. Difficult. Yeah. And some text file processing. I think for one-off cases, these are fine. But, if you're going to be processing CSVs consistently, repeatedly, then you probably want to use some sort of library for that. This is another stopping point, so I'm probably going to be speeding up because I got some more stuff to do. But we still have time for questions. Okay. Regex literacy. So why should you be able to read regexes when you can just go on the website and just get the regex for something and use it? Well, I'll show you why. So how do you read a regex that's really complicated? It's kind of the same as Please Excuse My Dear Aunt Sally, which most of us learned to solve mathematical equations like this. So you have to decompose and group a regular expression to read it. Another thing that helps is to be familiar with what this regular expression does. That'll help a lot. There's a big difference between something that parses a natural language and something that's just like an email parser or processor. So Another tactic is to write down strings that match the regular expression. So you might just start, looking through the regular expression and just, writing down possible strings it would accept, or you think it would accept. So what does this regular expression do? We're going to use the decompose method. Okay, we see a big group. We should always look for groups, not so much character classes, groups and operators. We can split by that group, and we see there's an alternation operator, and then we have multiple character classes. So this looks like something A to F, 0 to 9, that's probably hexadecimal. And we can have 6 of them. Or this one's very similar. We can have 3 of them. So we can have either a 6-character hexadecimal number or a 3-character hexadecimal number with an optional pound sign. That sounds to me like HTML color. And these are possible strings that you might have plugged in to match against that. What does this regular expression do? Well, a red flag is like it has an ampersand in it. If it has an ampersand in it, it's probably to match email addresses. So we're going to use the decompose method here again, and we'll highlight the ampersand because that's super important. And we have 3 groups. Yeah.
Yeah, not the ampersand.
Oh, at. Thank you. Okay, so we split by the at in the groups, and we see that it has like alphanumerics at the top, and underscores and periods and dashes, and then we have some digits and alphanumeric characters, and then it ends in either a letter or a period. So what are some? So this might be a regular expression that you yourself got from some internet site, and it didn't say. It just said email validation or something. But what does this really accept? Here are some possible accepted strings for this regular expression, and you might just use it, but someone could really just enter garbage, especially if you didn't validate again on the server side or something. And these might be perfectly valid within the spec, but you probably don't want them. So, how do you build regular expressions? Well, it's important to know what you want to match and know what you don't want to match. I know that sounds simple, but it's very key. So you start with something really simple, and you build up from it. But before we go into that, just because we can build a regular expression for something doesn't mean we should. What I'm going to do now is build a regular expression to match a date. But, should we do that? I'm arguing yes in this case because we're going to use it for natural language parsing. There's this site that some of you might use, Remember the Milk. And it's like a task sort of website. You can enter new tasks. So I can say RE presentation next Thursday. And it'll know March 18th. So this is an example of where you could use regular expressions, and it would be valid. You couldn't cast next Thursday. So we'll decide what we want to match. We're going to match a month, date, year, including the 3-month or 3-letter abbreviations. Here's a possible match and a couple things that are not matches. So we're going to start with something super simple. Just match a date in October. So we're going to just use all literals, and that's the regular expression, and that'll match October 20th. Okay, now we want to modify it to match each day in October. So we can add this. Now, there's something wrong with this, which I'll go over into the next slide, but basically what we're trying to do here is we're going to match a 1 to a 3 and a 0 to a 9 as the second digit. Okay, so that regular expression before didn't match the first through the ninth, so we're going to make the first digit optional. And there are things wrong with this. For example, you could have October 39th and October 0th. Not sure if that's even a word. But, you know, this is a very simple example. You could actually match all the days, but we won't go into that. Now we can expand it to match any year from 1,000 to 399. And that's here. 1 to 3. And then 9, 0 to 9 for the rest of the digits. And then, not sure if you guys saw here, but we have 0 to 9 repeated many times. We can simplify that to just having a 3, because that pattern was repeated 3 times. And then we can match October's abbreviation. We just add a group and an alternation operator to match October's abbreviation. And then we can add more months, May, December, and you see here we use the whole month names here and abbreviated here. And there's 2 alternate regular expressions. That's something you'll find. For matching a certain subset of patterns, there's multiple regular expressions to match that. So you might, that's something to keep in mind. Which regular expression we use here depends really on what we're doing. This regular expression actually lends itself better to being able to be loaded from a database. And you probably wouldn't need that in this case, but you might in another. And then there are other options. Do we ignore white space? Do we ignore punctuation? And that can be solved very easily. So these are just other random odds and ends. There's just what are called regex builders. They're interactive, so you kind of don't have to know the syntax, by memory. They'll help you build stuff. So let's say we had this Apple Snapple thing. So this is a simple example of the other regular expression I showed earlier. The dot means that I want to accept any character. And it matches both Apple and Snapple. If I remove this, that would just say match one character before the PPLE, and that would only result in Apple. Okay. So there's a list of these builders. Especially when you're starting out, you might just want to use these. It's whatever's your preference. I tend to not use them just because usually I'm not doing anything that complicated. So I figured I should do a custom project using demonstrating regular expressions for this presentation. So I did a little word jumble. And I'm not sure exactly what this kind of puzzle is called. I call it a word jumble, but it totally might not be. Is Scorpio Dev down?
You're on the VPN.
VPN.
Oh, we have to VPN from here, okay. Okay, so how this game works is you start with one word, and in each of these spaces you can change one letter to form a new word. And by the end, you get to the last word. So I'm not sure if you've ever seen this puzzle. I really like it. Although my version is super hard because I use every 5-letter word in the dictionary. And I don't know half of them. So how did I do that? Well, I think every Unix flavor includes a dictionary. So what I did was I found that dictionary file, and it's just a file of words, right? So I just did a grep 1, 2, 3, 4, 5 for a 5-letter word. And then I searched on that file, and it just spit out all the 5-letter words. I took that and I just saved that. And what I do is I load that file and I use that to as the source for these words. So what I do is I start with an initial word, and it's actually the last word that I start with, not the first. I just showed the last first. So I start with bully, and my method is to replace one single letter with a dot, which means any character in regex speak. So I use that regular expression to match against my entire corpus of words. So for example, I could replace the U in bully with a dot, and then search the entire dictionary for anything that begins with B and ends with LLY. That could be like Bally or Billy if that's in the dictionary. And I just repeat that kind of recursively to find that many words. So you can actually specify a starting word. What's a common word? Water. Okay, so we can start with a set word and continue, and we can also modify the length. So if we want a kind of more difficult challenge, we could have 7 words in between, and there's this hint feature. So that's basically it. I have this regular expression handout for you guys if you want it. It's a cheat sheet that looks kind of like this. And that's pretty much it. So if you have any questions, I'd love to answer them. Before I do, please fill out that survey. I really want to get better at presenting, so that's just for me. And I really appreciate you filling that out. Again, feel free to be harsh. Have a thick skin. And any questions? No? Okay, well, I'm going to send out the slides at some point. Feel free to send me any questions. And if you guys ever have any interesting programming problems, I love to hear about them. And, if you need someone to look at code, I like to read code too. I feel you can kind of get a sense of someone's character by their code. So I read them like novels. Thank you.